Hi, welcome back. So let us now derive formulas which can relate the A, V, S, and T based from our main kinematic equation. So let's start with the velocity as a function of time. So from our main kinematic equation, we have the A, which is constant, derivative of B with respect to T. So we have here the velocity as a function of time. So we have dv over dt. So let's integrate these equations. So A dv over dt can also be written as, when you move the dt there, A dt is equal to dv, or you can swap the position of a dt and b dv. I mean they are by the way, they are the same, but let me put the dv there so that we can later on find the value of b on this side, on the left side. Okay, so before we integrate this a dt dv, let us assume that at time 0 our v is equal to v sub o. Okay, so at time 0 initially our v, or velocity, is can be represented by this VO. So based from here dv is equal to a dt, we can directly integrate both sides since we already do the algebra to separate dv and dt there. Okay, so from dv is equal to a dt, then integrate from, let us integrate dv from initially b sub 0 up to its final velocity, and then from time 0 up to time t. Okay, so dv, the derivative of dv, I mean the integral of dv is just v from v sub o to v, and then the integral of a dt, wherein our a is constant, so we can copy the constant and then integrate dt, which is equal to t from 0 to t. Then from here we can now substitute the limits from v sub 0 to v. So the technique there is that from b we need to we need to find the v sub 0 up to b of this velocity here. So from velocity here we have to copy this v, then minus the initial v sub 0. Yan. Then for a, since this is constant, then we can copy a, and then for time t we can now copy this t minus the initial, which is 0. Okay, so to simplify, we have v is equal to, v minus v sub 0 is equal to a t minus 0, a0 or just 0. Okay, so from this we can now do the algebra to find the v. So v is equal to at minus or plus, since we move this negative v sub 0 on the right side, so we have plus v sub o. So therefore this is now our final formula to find the velocity as a function of time. So we have v is equal to at plus v sub 0. Okay, so another one, we've done this velocity as a function of time. So let us now move on to the position as a function of time. So we have the main equation. We have v is equal to ds over dt. So let us assume that initially when time is equal to 0, our s is equal to s sub o. Okay. So from our equation, since we do not have the function of time there for our v, we can now use our derived v here. Okay, so since v is equal to at plus bo, we can substitute that on our v, where let me at plus v sub 0. Okay, so instead of using this v, we can now substitute the value of our derived v, so that we can now have the v as a function of time there. So we have, instead of b, we substitute this. We have at plus v sub 0. This is now our v. It's equal to ds over dt. And then from here, we can now do the algebra to move the dt on the upper side or to the left side. So we have at plus v sub 0 times dt is equal to ds. Okay, I only move the dt on this side. At plus v sub 0 dt is equal to ds. Okay, so from here we can now integrate both sides. This is a function of dt, and on this side we will integrate ds. Okay, or you can also swap the position if you want. So for me, I swap this position plus v sub 0 dt. Yeah. So from here, you can now integrate both sides, ds, and this other side, dt. Okay. So let us now integrate ds from initially 0 to s, and then integrate at plus v sub 0 dt from 0 to t, final t. Okay, so you can also before integrating this, you can also do the algebra and distribute the dt. So we have a integral of 0 to t dt. So let me distribute this dt. We have dt, at dt, but since a is constant, then we can write this outside the integral sign. So we have a integral of t dt from 0 to t, and then we have v dt. So we have the integral of v dt from 0 to t. Okay, so from here we can now simply integrate the ds, which is equal to s, from so to s, and then t dt. So we need to copy the constant, and then the integral of t dt is just t squared all over 2 from 0 to t, plus the integral of dt is just t, then we copy bo, okay, from 0 to t. And then from here we can now substitute the value. We have s minus S sub O is equal to 1/2 T minus 0, then squared, plus V sub 0 T minus 0. Okay. So simplify, we have S minus S sub O is equal to 1/2 A. T minus 0 is just T, so we have T squared plus T minus 0 is just T, V O T. Okay. So from here, we can now solve for the value of our S, or position, is equal to 1/2 AT squared plus VOT plus S sub 0. Okay. So the formula means derived is just position is equal to 1/2 AT squared plus VOT plus S sub 0. VO is the initial velocity, SO is the initial position. Okay. So S is equal to 1/2 AT squared plus VOT plus SO. Okay. So we've done with the velocity as a function of time, and then we've also done with the position as a function of time. Then lastly, we will solve the velocity as a function of position. Our last equation.